I'm Stephen Parfenik, and I'm the Senior Vice President at Sheridan. I'm responsible for all things finance and administration, which would also include facilities. It includes our IECMP plan, which is what we're going to talk about today. It includes human resources, purchasing, procurement, security, and just about all of those things that are really required to run a really great post-secondary institution. Sustainability is an important part of who we are at Sheridan. We're in the middle of a 6-year Integrated Energy Climate Master Plan, or IECMP. And we went down this path a couple of years ago because we recognized that as an institution, our energy footprint was incredibly large. And we realized that one of the places we can save money would be by investing in sustainable products, as well as investing in materials and equipment that are much more energy efficient than the ones we were currently using. We want to invest as much as we can in our students at Sheridan. And as government funding declines, we have to look around and see where we're spending our dollars that are important for students, but where we can make efficiencies.
So Office for Sustainability is essentially the clearinghouse for all of our strategic initiatives, both operational and curricular, around sustainability. For a number of years, our faculty and staff had indicated a need for there to be a centralized resource for implementing all of the strategic initiatives around sustainability at the college. We saw there was a need for a strategic direction and approach to energy, and there was a strategic need for an approach to waste. And those were the two we decided in parallel were the first things we really had to tackle. So what we'd found with our bins on campus prior to implementing a zero waste program is that we had a mix of different bin types, and what we really needed was a very consistent approach so that we could communicate to our users and stakeholders, this is how the bins work. And at every campus they go to, every location they find around Sheridan, it would be a consistent same approach. Part of what's happening with the bin strategy is that we're seeking to separate the streams. And this is beyond just achieving a diversion from landfill. I mean, one of the key things we're after is to remove all of that valuable resource. So in particular, organics that can be composted or turned to fuel. The recyclable content, the glass, the plastic, the metal, that can be reused into other products. And then second beyond that is to really begin to shift the Sheridan community's perception of waste as inevitable. This idea that if it ends up in the bin, it has to go to landfill. But instead really create this perception that the waste is really a resource, and it's really a resource that can be reused and put to other use in its lifetime. Energy Group took the opportunity to meet a number of vendors and consultants and people who work in energy planning and wanted to hear what they had to say about how an energy plan gets built. And what the group heard was actually a number of things that are essentially traditional approaches to energy. And while these are absolutely valid approaches and they work very well in a lot of situations, they couldn't really achieve the deep savings we were after, and they didn't inspire the kind of behavior change we wanted to see within the organization.
One of the senior managers from Sheridan came and talked to me and was interested to know how community scale planning could be applied to a college environment. So we did this jointly. So in other words, it wasn't a case of the clever outsider coming in and coming up with all kinds of wisdom. It was a joint work. We formed a team between what we called a mentoring team and the actual project work team.
This was the point we realized that what we were hearing was the opportunity to achieve breakthrough energy savings really beyond 50%, for example. That we had a flexible plan that would allow us to adapt to changes either in how we were using our facilities or in technology that was upcoming. And then also what we heard is an approach that allowed us to leverage early gains we might have in retrofitting buildings to bigger savings when we went to retrofit central plant equipment. That was the innovative spark we wanted. That was the deep savings we were looking for.
From the beginning, faculty, facilities, finance administration were actively involved at senior levels. So this was an institution conversation, Sheridan conversation, not a technical conversation from facilities or a financial conversation. And part of the process is what we call developing the baseline and the base case. Where are we? How do we compare? And we looked at some obvious things, which is what's our energy use? And we compared it not only with colleges and universities around Ontario and around Canada, but also with some colleges where we knew there were good practices in North America in general, in the USA and Canada, but we also compared it to other parts of the world. Then as we developed the plan, the faculty were very supportive of including the students in the process.
So in order to get engagement with the program, and also because this was a mentoring role and Sheridan is a place of learning, we wanted to help students understand what master planning is and what energy is. So I came in and I helped the students understand how to do energy modeling on a larger scale. And so I taught them how to use the software, and then I taught them about how to collect data. We've done projects like this before, and what usually happens is that I will model the buildings, but I won't model every individual building. I'll model generalized buildings, and then I will apply that to various locations on site. Now, what happened here is, because we had the student workforce, which was great, is that they got to model each building individually. And the use of having each building modeled individually is that an energy model reflects the design intent of a building. And so if you have the right data in it, which the students went out and collected, you can then use it to audit the building in future years. So you can meter data against what the model is saying. You can tell if the building is performing as it should be, or if it's not performing as it should be. You can apply efficiency measures and see how that would save energy and then apply them in real life. It's an ongoing process that you can use the model to help analyze what's happening on site. So that was a huge added value for the Sheridan project.
Right up front, we were able to engage about 100 students. All of that data was then fed into our integration workbook, and essentially the team was able to then derive from all of that wonderful data an approach to go forward and implement the plan.
And we were very supportive of that. The difference was if we tried to do that in a commercial project, the cost would be prohibitive. So we've ended up with a plan where it's not something written by a handful of technical employees, technical members of the college staff and a few consultants. It's a plan that's been genuinely created and owned by the entire college community.
So as we completed our planning process, we had a waste plan more or less coming along, we had an energy plan coming along. Office for Sustainability really had a challenge of trying to put that in a consistent envelope in a way that people could identify that these are a broader range of sustainability initiatives that are aimed at making the institution better. What we hit on was the fact that we're really interested in that aspirational goal. Can we get to zero? And we picked up zero as this is the aspirational goal we want. This is the thing, and hence we get mission zero.
Our company has worked in and around Sheridan for many years. I've seen many different types of lighting as well as being integrated through different types of controls. And to this day, I haven't seen a system that is so flexible as the one being installed in Sheridan today.
It's what they call a DALI-based protocol, digital addressable lighting interface. We have lighting control panels distributed through the building, and then we have different DALI loops.
Previously, lighting didn't have the flexibility and adaptability, I guess, to classrooms as it does with this system. Before, we would basically be dealing with on and off, and when it is on, your light level would be your light level. Now, with everything being software driven, everything can be manipulated in lighting levels, different areas of each room, which now makes it very adaptable. One classroom may change over the years to be a makeup studio or a sound studio. Now, through the software and just programming those lights, we're able to change the light levels and the zoning within each room, which makes it much more flexible, as opposed to in the past, we would physically have to go in there and change lights to get more light, remove lighting to reduce that lighting.
So as part of the Integrated Energy and Climate Master Plan, one of our key components is to reduce our energy consumption by 50%. The first thing that we focused on was the building automation system. If you're not able to control your mechanical systems, then typically you're losing energy. Each building that we renovate, we go through the entire mechanical system to see how the controls are performing, and we want to also see how the HVAC is performing. So we work with air balancers to diagnose what all the faults are in the system, And then we work with consultants and our maintenance staff to come up with a solution. From there, we execute that solution to create a more comfortable environment for occupants.
The new buildings, we have our HMC2 building that's under construction up in Mississauga. It's the second phase on campus. It'll be ready for occupancy for students for September 2016. Our other building that is under construction right now is at our Davis campus. It's primarily for relocation of our skills training center here in Oakville. The new buildings, we've adopted an international standard pretty much. North American's aggressive, but international standards are far more aggressive. So we're actually building from 70 to 100 kilowatts per square meter per year to operate it. Effectively, that's probably 40 to 50% better than most of the buildings built right now in Ontario. Part of the new Davis campus build is a new energy center that will power the entire campus.
One of the basic principles of the energy plan was to make the college as a whole a living laboratory in high-quality energy management. To have this as a well-executed, attractive piece of modern engineering with glass walls open to the campus. So in other words, not do the usual trick of hiding innovation away down in a basement somewhere, but actually exposing it as part of who Sheridan is and what Sheridan is as an institution relative to its energy innovation.
Right now, we're saving enough electricity on an annual basis to power 350 homes. That's a $500,000 savings right now to Sheridan College. We're diverting 350 metric tons of waste from landfills. And lastly, we're saving 10.5 million impressions on an annual basis and saving trees because we're photocopying less. So here we are in 2015 with all of those great statistics that I just talked about, and we're nowhere near done.